Hey, hi everyone, welcome back to this video series on Cisco Packet Tracer, configuring VLANs and trunks. A switch breaks up collision domains and is a single broadcast domain. So how about breaking the single broadcast domains into multiple ones? VLAN, virtual LAN makes this possible. And on a single switch, we can have multiple broadcast domains, but once you create multiple VLANs on a switch, it becomes tedious to replicate the same configuration on all of the other switches. This is where VTP, VLAN trunking protocol comes in. So we have multiple switches with different VLANs and VTP, making management easier. But how do we make a device in one VLAN communicate with a device in another VLAN? We'll cover this in InterVLAN routing, creating VLANs and VTP domains. VLAN is a technology used to partition a single layer 2 network into multiple broadcast domains. This is done to restrict communication between devices that share the same broadcast medium. However, these devices can communicate with one another through a layer 3 device such as a router. This is similar to connecting devices to different switches and then connecting them all to a router to separate broadcast traffic. As more and more VLANs are created, it becomes tedious to replicate the configuration across all switches, which was why VTP was created. We'll first learn about creating VLAN and assigning ports to it. VLAN 1 is created by default on all switches and all ports reside in it. This VLAN is called the management VLAN. To create a VLAN, use the following command: sw1 config VLAN 2. The VLAN ID can be between 11001, the IDs 1002, 1003, 1004, and 1005 are reserved. Once this command has been entered, you are taken to the VLAN sub-configuration mode. This is the place where we can assign a name to the VLAN. SW1 config VLAN name finance. Assigning a name to a VLAN is optional. By default, the name is VLAN 0002. Next, we will assign a few ports to this VLAN. To assign many ports to a single VLAN, the range command can be used, which then selects multiple interfaces. SW1 config interface range F0/1020. To assign these ports to VLAN 2, use the following command: SW1 config if range switch port access VLAN 2. Let's verify if the ports were indeed assigned to the correct VLAN. SW1 show VLAN. Note that in the above example, some of the output has been omitted for brevity. We will now create a technology with 3 switches to demonstrate VTP. VTP has 3 modes: server, client, and transparent server. This is the default mode of VTP. In this mode, switches are allowed to modify their VLANs and send VTP advertisements. Client. In this mode, switches listen for VTP advertisements from other server switches. Client switches aren't allowed to modify their VLAN database locally. Transparent. This mode works independent of other switches. In this mode, the switch only forwards the VTP advertisements it receives and does not generate any, neither does it modify its own VLANs based on the VTP advertisements. The following topology will be used for this demonstration. In the first switch VTP server, we will have 4 VLANs with different names. Then we will set all the switch ports to trunking. VTP server config interface FA0/1 VTP server config if switch port mode trunk. VTP transparent config interface range FA0/12. VTP transparent config if range switch port mode trunk. VTP client config interface FA0/1. VTP client config if switch port mode trunk. Since VTP is already in server mode, we will adjust the VTP domain name and set a password. VTP server config VTP domain my office, changing VTP domain name from null to my office. VTP server config VTP password S3C capital or ET, setting device VLAN database password to S3C capital or ET. Moved on to the second switch, VTP transparent, and make it transparent. VTP transparent config VTP mode transparent. The final task is to move the third switch, VTP client, to client mode. VTP client config VTP mode client. You do not have to change the domain of the switch, as changing it to client will make it pick up the domain name for the server. However, it is necessary to set the VTP password. VTP client config VTP password S3C capital or ET. The configuration is done now. Use the show VLAN command on the VTP client switch to see the new VLANs. This example is only to demonstrate VTP. This topology won't allow normal communication between VTP server and VTP client, as the switch in the middle, VTP transparent, doesn't have any of the VLANs configured. InterVLAN routing with routers and layer 3 switches. Although VLAN is used to split the broadcast domain, it is necessary to enable communication between two or more VLANs at layer 3 using IP routing. This is called InterVLAN routing and can be configured using both routers and layer 3 switches. This requires allocating a different IP subnet for devices in each VLAN. We will configure InterVLAN routing by connecting the router to a switch using a single link. All the traffic to other VLANs passes through this link to the router and back again through this link. This method of configuration is also called router on a stick, as a single link to the router handles all traffic. InterVLAN on a router. We use the following topology for this setup. As stated earlier, each VLAN will have IP addresses from different network ranges, and the router's interface will have 3 IP addresses, each belonging to a different network. After IP addresses have been assigned to all PCs, create the necessary VLANs on the switch and assign ports to them. SW1 config INT range FA/23. SW1 config if range switch port access VLAN 10. SW1 config if range INT range F0/45. SW1 config if range switch port access VLAN 20. SW1 config if range INT range FA/067. Switch SW1 config if range switch port access VLAN 30. Configure the switch port that connects to the router as a trunk link. More on this in the switch to switch trunk links section. SW config INT F0/1. SW config if switch port mode trunk. Now moving on to the router portion of the configuration, bringing the interface up. R1 config INT F0/0. or one config if no shutdown. We will now create sub-interfaces. Each will have its own IP address in a different network. Or config sub if INTF 0/0.10 or one config sub if encapsulation .1Q10 or one config sub if IP address 10.10.0.1 255.255.255.0 or one config sub if INTF 0/0.20 or config sub if encapsulation .1Q20 or one config sub if IP address 10.20.0.1 255.255.255.0 or one config sub if INTF 0/0.30 or one config if encapsulation .1Q30 or one config sub if IP address 10.30.0.1 Note the encapsulation command here. It specifies the VLAN ID the interface will handle. That's it. Now to test the connectivity between the host and different VLANs using simple PDUs or a ping. The first packet will always time out as it takes some time for the address resolution protocol to complete. InterVLAN on a layer 3 switch. The only layer 3 switch present on Packet Tracer is 3560 24PS. We will use the same topology by replacing only the router with the layer 3 switch as shown in InterVLAN on a layer 3 switch. The only layer 3 switch present on Packet Tracer is 3650 24PS. We will use the same topology by replacing only the router with a layer 3 switch as shown in the following screenshot. Creation and configuration of VLANs is the same on the layer 2 switch, hence it won't be repeated here. So we'll move on to the layer 3 switch straight away. Since the switch-to-switch link on a layer 3 switch was set to trunking mode with the switch port mode trunk command, the same port on a layer 3 switch will also be in trunking mode. This can be verified as follows. MSW1SH interface trunk. The trunking status indicates this. More on how this port automatically moved the trunk will be discussed in the next section. Switch to switch trunk links. We will configure what is called SVI switch virtual interface, which will act as a layer 3 interface for each VLAN. MSW1 config INTVLAN 10 MSW1 config if IP add 10.10.0.1 255.255.255.0 MSW1 config if INTVLAN 20 MSW1 config if IP add 10.20.0.1 255.255.255.0 MSW1 config if INTVLAN 30 MSW config if IP add 10.30.0.1 255.255.255.0. These interfaces will stay down at this layer 3 switch. Doesn't have VLANs 10, 20, and 30, so we'll create them as follows. MSW1 config VLAN 10, MSW config VLAN 20, MSW1 config VLAN 30. Each command is entered. The associated SVI will come up. IP routing has to be enabled. MSW1 config IP routing. Use the simple PDU tool to test the connectivity. Switch to switch trunk links. When two switches are connected together, there must be a mechanism to identify the VLAN the frames belong to. We aren't talking about the physical layer, but about the data link layer. When two switches are connected together, each one needs to know to which VLAN the traffic is destined for. This is where VLAN tagging comes in. When a frame moves over a switch-to-switch link, the source switch tags the frame with the VLAN ID, and switch-to-switch link is known as a trunk. Following is a screenshot of an inbound and an outbound PDU captured in simulation mode when a PC in VLAN 10 pinged a PC in VLAN 30. Notice the TCI tag control information field that contains a hexadecimal value. It denotes the VLAN ID, so the inbound PDU has 0xa, which is a VLAN 10 source, and the outbound PDU has 0x1e, which is a VLAN 30 destination. Analyzing broadcasts in the simulation mode. The concept of VLAN is to split the broadcast domain. So in this section, we will see how broadcasts are handled in a VLAN environment using the simulation mode. Use the same InterVLAN topology we used previously from PC0 to ping 255.255.255.255. This sets the destination MAC address to ff.ff.ff.ff.ff, which is the layer 2 broadcast address. Switch to the simulation mode to see what happens. The switch receives an ICMP packet from PC0 and sends out 2 copies of it, one to the router and another to PC1. If this network weren't divided into VLANs, the ICMP packet would have been sent to each and every PC connected to the switch. Summary. In this chapter, we learned how to use the devices in Packet Tracer to create VLANs and to set up VTP to make their management easier. We also configured InterVLAN routing with both routers and layer 3 switches. So by now you'll be familiar with SVIs of these layer 3 switches. Finally, we learned about the difference between normal switch PC links and switch-to-switch links, which are also called trunks. The simulation mode of Packet Tracer is of immense help here, as it enables visualizing the packet flow in a VLAN environment. So this concludes my video series for Cisco Packet Tracer. I hope you like listening. So please consider like, sharing, and subscribing, and thank you.